What are the products of the following reactions? So I have 3 reactions on this one because they're kind of short reactions. They're not that much. So let's look at the first one. And in the first, we have 2 things going on. So 1 and 2. So let's do the first one first. And that's CH3, ClAlCl3, which means this is a Friedel-Crafts reaction. So Friedel-Crafts, that's fine, but where will it go? So the isopropyl group that I already have in the benzene ring is an activator, so I can actually have this CH3 group, the methyl group, ortho or para, and I will have it more on the para than the ortho because the isopropyl group is pretty bulky, and so it will cause steric hindrance, and so these 2 places, these 2 ortho positions are not very good, okay, for substitution because of steric hindrance. Then KMnO4 is the next reaction. So in the second one, we're actually going to be doing oxidation. So when you do oxidation, now you're going to be completely getting rid of the side chain. So whatever you have here, so especially if you have any alkyl groups, both will be gone. So COOH, and then on the para position also you have a COOH. Okay, so this is benzoic acid twice. No, okay, but in any case, so you have 2 benzoic acid or 2 carboxylic acid groups. Now, ideally speaking, if you had wanted to make this relationship, you would not have been able to do that because COOH group, the carboxylic acid group, is going to be a meta director, so a para position would not have been possible. So this is the best way to get a para position for COOH groups to each other. Right, so that's the first one. And remember, because the isopropyl group is also an alkyl group which also has an H over here, because of that H and because of this one hydrogen over here, both of these groups can be oxidized. If one of them was a T-butyl, then you cannot oxidize it. Okay, I know, very trivial information. All right, let's look at the next one. In the next one, we have 2 benzene rings, and we are trying to do this reaction, which, if you remember, this one is the Gattermann-Koch synthesis, and the Gattermann-Koch synthesis is the one for making benzaldehyde. All right, so which means we're adding an aldehyde group. So the question is not so much about the Gattermann-Koch synthesis, it's actually about the benzene ring. So which ring is going to be more activated, the first ring or the second ring? And the second ring is more activated because there is a CH2 group over here. Okay, so it means that my substitution is going to take place in the second ring. Okay, so here let's go ahead and write the product. So here the keto group is fine, that's all right. Now nothing happens to the CH2 group. Okay, it's just a matter of where the CHO is going to go. So the aldehyde group will preferably go to the para position. Again, not going to go to the ortho because of steric hindrance. All right, so if there is, it's going to be a very small amount of product, majority if it's going to be para. So that is the second reaction. Let's look at the last one. And the last one is given to us step by step, so which is nice also. And it could have been given as 1, 2, 3, but this is kind of nice to write it this way. So the first reaction is with toluene and KMnO4, which means that I'm oxidizing my methyl group. This is a side chain reaction. And the next reaction we have is nitration. Now this reaction is going to happen on the benzene ring. So the carboxylic acid group is going to be a meta director. So it means that my nitro group is going to go to the meta position. The next reagent I have is LAH. LAH is lithium aluminum hydride, which is a very powerful reducing agent. And so because it's a powerful reducing agent, it's going to go ahead and reduce both the groups. Okay, and so that means I will have CH2OH. So the carboxylic acid will get reduced to the alcohol. Remember, the carbon is still going to be there. Okay, so the carbon is still there, and the NO2 is going to get converted into NH2 because of reduction. So these are the groups that we will form as a result of these series of reactions.